Hello, discrete math fans. I'd like to go back to think about Euler's problem about the bridges of Königsberg. And I want to make a new definition. This is to define what is an Euler circuit. So an Euler circuit is a circuit that contains every vertex and every edge of the graph. So that is, an Euler circuit is a sequence of adjacent vertices and edges that has at least one edge, starts and ends at the same vertex, uses every vertex of G at least once, and uses every edge of G exactly once. Notice the difference in the wording. Vertices can be visited more than once, but edges can be visited only once and exactly one time. What we'd like is a simple way to check a graph to see if it has an Euler circuit. Now we're going to give exactly that condition, but we are not going to prove it here. If you find yourself interested in the proof of this theorem, you should read it in the book. Here it is. This is the whole theorem. It's very straightforward to check to see if a graph has an Euler circuit. And the theorem says that a graph has an Euler circuit if and only if it is connected and every vertex of the graph has positive even degree. So having even degree is the important thing here. Now let me remind you of the graph that we talked about in the bridges of Königsberg problem. This was the graph. Now we see the theorem about Euler circuits shows us that this graph does not have an Euler circuit. The graph is connected, but it has vertices which do not have even degree. Now the rest of this section has some information about Hamiltonian circuits, and that relates to the traveling salesman problem. We won't specifically be going over these ideas much. They make for excellent bedtime reading. Okay, that's all for now.